Hello, can everybody hear me? Who am I? I'm teacher Ji Kai. Yeah, can anybody hear me? In my Amos class, welcome. Oh yes, so you can hear me, so maybe let's start. Okay, so yeah, I think all of you have already finished the TASMO sample paper, right? So here, I just directly tell you the answer here. So the first question, we need to find the value of 48 minus 36 divided by 3 times 4 and plus a 9. So you just do it, right? So it's 48 and 36 divided by 3 times 4, it is minus 12 times 4, right? So, and we plus a 9 here. So the answer here will be 48 minus this one, also 48, right? And plus a 9. 48, 48, we have the same one, and we cross out. So we cross it out, you can see the answer here is 9. So you choose D, right? So how about the second question here? So for the second question, we want to find which letter is on the face opposite to M. So for the faces, we can make it into two categories, right? So the first one is the opposite one. This is what we want to know, right? This is what we want to know. And also, we have the faces which is next to it, right? Next to it. So if we want to get the faces next to it, so you just observe from the figure, right? So we want the M here. So what are the faces next to it? We have K, we have I, and this is also M, we have O, we have P, right? So we have K, I, O, and P. So among it, which one is not next to it? The U here, right? The U here is not next to it. So the opposite here is U, so you choose D. Right. So this, the question 3, it is a statistic question. So we want to know, how many more books did he sell on Mondays and on Tuesday? So here, right, if we have statistics, we just make the units here, right? So here we make one grid as 1 unit. So for the Monday here, we have how many units? 8 units. Tuesday, 3 units. Wednesday, 5 units. And 8 units, 7 units, 5 units, and 1 unit. And then we know what? He sold 999 books in total during the week. So here, right, we can know all of the units here, they add up equal to what? They add up equal to 999, right? So we can build the equation here. 8U plus 3U plus 5U plus 8U plus 7U plus 5U plus an U. You can find the sum here, it will be equal to 999. So you sum it up, you can find the total here is 37 units. And we have 999 here. So you just divide 999 by 33. You can know 1 unit, it will represent 27 books. So what is it asking? How many more books did he sell on Mondays and Tuesday? So the answer here is how many units? 8 units minus a unit, right? So the 7 units equals to 7 times 27. So the answer here is 1, 8, and 9. So what is the choices here? Of course, we have 1, 8, 9 here. The D here should be the correct answer, right? So let's go to the fourth question. It is about the divisibility rule. So we have value of A plus B plus 3 plus C equals to 173A and divisible by 9 here. Okay, and divisible by 11, divisible by 6. So for this question, you need to know the divisibility rule, right? So let's start with the divisibility rule of A here, right? Let's start with the divisibility rule of A here. So we have 173A here, right? It will be equal to what? It will be divisible by 9, right? So it is a multiple of 9 here. So the divisibility rule is 1 plus 7 plus 3 plus 8. It will be a multiple of 9, right? The digit sum here. So once you know the digit sum, you can just have a try about the a here. A here will be equal to 7, right? A here will be equal to 7 because 1737 plus 18, a multiple of 9, right? So how about B? 173B, a multiple of 11 here. So what is the divisibility rule of the 11? The odd digit group minus the even digit group, right? So what is on the even digit group? 7 and B, right? 7 plus B. And we minus the odd digit group, which is 3 and 1 here, right? So we minus 3, we minus 1. Oh, it should be plus, right? So it will be what? It will be 3 plus B here, right? And we know the difference here. It should be a multiple of 11. So B here can only be 8 because 3 plus 8 will be equal to 11. So we have already know A and B. Let's go to C here. So C here, 173C here, it is a multiple of what? A multiple of 6, right? So 6 here, it equals to 2 times 3, which means it is both multiple of 3 and multiple of 2, right? So here, if we want the things to become multiple of 3, we also do the digit sum here, right? It is 1 plus 7 plus 3 plus C. It is a multiple of 3. So C here will be equal to what? Equal to 1, equal to 4, equal to 7. And how about mode of 2 here? If we have mode of 2, it means what? It means the last digit, which is C here, right? The last digit, which is C here, is even. So we know C only has 3 choices, 1, 4, and 7. And we know C here is even. So what can C become? C can only become the 4 here, right? So we know the answer. If we add them up, A plus B plus C, it is what? 7 plus 8 plus 4. So the answer here is 19, right? So A, B, C, D, oh, none of the above is correct. So we choose E here. Alright, we choose E here. And oh, this one is an inclusion and exclusion problem. So Aiden, who wrote the first 20 positive integers on the blackboard and erased mode of 2, erased mode of 5. So how many integers were still there? So who will still remaining? Is multiple of 2 remaining there? No. Is multiple of 5 remaining there? No, they are erased. And how about multiple of 2 and 5? Also erased, right? They were erased at the first time. So who will remain? Not multiple of 2 and not multiple of 5, right? So it is neither multiple of 2 nor multiple of 5. So it is this part we are going to ask, right? So for this kind of inclusion and exclusion problem, we need something to help us. It is called a Venn diagram, right? So we can just draw the Venn diagram. So this is the total number, and we know it is 2020, right? It is 2020. And we have 2 sets. The first set is multiple of 2. And the second set is mode of 5. And what are we talking about? We are going to learn about the part with the star here, right? The part with the star here. So for multiple of 2, we have how many numbers? Right? 1, 2, it is a mode of 2. 3, 4, we have a mode of 2. 5, 6, mode of 2. So it means every 2 number, we have 1 mode of 2, right? So in 2020, we have divide by 2 equals to 1010. We have this kind of number being a mode of 2, right? How about mode of 5? Every 5 number we have mode of 5, right? So we just divide by 5. 4, 0, 4. Then how about multiple of 2 and 5? It's calculating the LCM of 2 and 5, right? So it is 10 here. 2020 divided by 10, it will be 202. This is it. So we are calculating what? We know mode of 2 it is 1010. Mode of 5 it is 404. And the middle of it it is 202. So we are going to calculate the star here. The star is which part of it? None of it. But we can still calculate the part based on these three parts, right? Is the answer with 2020, which is the total, and we minus the things inside the two sets, right? So it is minus this 1010 plus 404 minus 202, right? This is all the things inside the mod of 2 and the mod of 5 sets. So you will see it is 2020, we minus 1212, right? 1212. So the answer here is 808. So which part is it? The B here will be the correct answer, right? The B here will be the correct answer. So yeah, this is the question 5. And let's talk about the question 6. Oh, there are 5 natural numbers and their average is 9, and the first 3 is 7, the last 3 average is 11. So what is the middle number? So here, when you see the average and you know there are how many numbers, of course you can know the total here, right? So we can just start with the total here. The total of the 5 numbers is what? We have every number average is 9, and we have 5 numbers here, so the total here is 45. So for the first 3 number, we know the number of the average here is 7. So 7 as an average, and then we have 3 numbers, so 21. So for the last 3 number, the average is 11. So we have 11 and we have 3 numbers, 33. So once we know the total of these parts, so what are we going to do about the middle number? So once you know these 3 parts, we have one question. For the middle number, it has been calculated how many times for the first 3 plus last 3. If we add them up, right, the middle number has been calculated how many times? 2 times, right? So the middle number 2 times. So it's just we plus the first 3 and the last 3 and we minus the total. We will remain the middle number here, right? So the answer is easy, right? 21 plus 33 minus 45. So what is it? It will be 9. Right, it will be 9. So which part is it? Oh, we have a C here, right? So the answer is C. So any questions for these 6 questions? Okay. Yeah. Okay, so let's go to the 7th question, right? The 7th question. So yeah, we have a dot here. So what is the area of the shaded portion? So for this kind of this dot here, right, we can see, oh, we have the grids here. So once you see the grids, it is calculating what? It is asking about what? It is asking about the pixelium, right? So now for the pixelium, do you still remember the formula for the triangular grids, right? We are having the triangular grids. Yes, it is the inner dots plus border dots divided by 2 minus 1 and do what? And we times the 2 here, right? And we times the 2 here. So for the triangles, we have this formula. And we calculate the number of triangles, right? So for the inner dots, we have how many dots here? You just count, right? We have 7. And how about the border dots? 22 here. So you can see the triangles, we have 7 plus 22 divided by 2 and minus 1 times the 2. So it will be 17 times 2. So we have 34. So is the 34 our answer here? Is it our answer? So please note, for this pixelium, we have the answer, but it is the answer about what? It is the answer about the number of triangles, right? So once we know it is the number of triangles, when we want to get the area, we need to do, we need to multiply the area of each triangle. So what is it? 4 cm squared, right? So the area It's just 34. We times the area for each triangle. So it is 34 times 4. So the answer is 136 cm squared. Which one is correct? Nothing is correct. So E here should be the answer. Alright. So now let's go to the question 8 here. Oh, this is an aging problem, okay? And yeah, can we make use of the difference of the age in this question? I think it's hard. So once we cannot use the difference of age to solve this kind of question, what should we do? We should use the algebra to solve it, right? So here we have Alice, we have Bob, we have Carlo, and we have this year, we have next year, right? We have next year. Oh, not next year. We have 1 year ago, so it is not next year. We have the past. So, yes, we know this year Alice is 5 years old. So 1 year ago, Alice is how many years ago? 4 years ago. 4 years, right? 4 years old. And we know Bob is 13 years younger than Carlo. So we set Carlo as X age, right? So the Bob's age is X minus 13. So it is 13 years younger. And how about the past year? 1 year ago, Carlo is, it's for this year, Carlo is X years old. So 1 year ago, Carlo is how many years old? X minus 1, right? So Bob here, easy, right? X minus 14. So once we have built this table, we know everybody's age for this year and 1 year ago. So we can just think, oh, do we have another conditions here? Yes, we do. Carlo's age was twice the sum of the Alice and Bob's age. So how can we make use of this condition? It is asking 1 year ago, so it is this part, right? So Carlo's age is what? X minus 1. And it is twice the sum of the Alice age and Bob's age. So, yes, you can build an equation like this, and it will be like x minus 1 will be equal to 2x minus 20. So x here will be 19 here. Yeah, x will be 19 here. So what is the question asking us? The sum of the three children's current ages. So yeah, we have already know what is the value of x. So it is easy for us to get it, right? So x here is 19. So this age, it is x minus 13, 6. Right. So the answer here is easy. We just use 5 plus 6 plus 19. So it is 11 plus 19, so we get a 30. So we know, yeah, they are 30 years old. So now let's go to this one. Yeah, this question, number 9, it is about the number theory and about the prime number and composite numbers. So here, yes, we see 5a plus b equals to 2027. So we have an equation in the prime number and composite number. So what do you think of? You need to think about the parity here, right? So here, we know 2027, it is an odd number, right? We know 2027 is an odd number. So odd number, it is a sum. It should be what? It should be an odd number plus an even number, right? So we have 5a plus b, one odd, one even. So we need to discuss which part is odd and which part is even. So we have two categories. The first situation here is 5a, it is odd. And b here is even. So once we know b is a prime number and b is even, so what is the value of b? b is 2, right? The only choice for b is 2. So now we know 5a here is 2027 minus 2. It will be equal to 2025. 5a is 2025. So a here is 405. So is 405 a prime number here? No. Because you can see the one digit here is 5. So of course it is a module of 5, not prime. So this case, it would not be the answer, right? It cannot be the answer. So no. So how about the second case? 5a is even and b here is odd. So 5A is even. So yeah, we can see 5A even. And A prime. So you can see A is also even prime. So A can only be 2 here. So what is B? B is 2027 minus 5 times 2. So you can see it's 2017. So is 2017 a prime number here? Right. It's hard to tell. But if it is not a prime number, what should the answer be? We don't have any of the answer here, right? So you just know that it is prime, right? You can verify it by divide by 2, 3, 5, 7, blah blah blah, right? But now I can tell you it is a prime number. So yeah, this one is correct. So the answer here is easy, right? 2017 plus a 2. So it will be 2019. The B here. Yeah, this will be the answer. So yeah, the last question in the choosing section, yeah, the multiple choice problem. So we have a 4-digit number forming by 2 2's, 1 0 and 1 5. So we call it a good number. How many good number are there? Okay, so now we have a 4-digit number. Like this, we have a 4-digit number here. And yeah, we have 2 2's, 1 0 and 1 5. So first, if we have each number being different, so we just first assume the 2 2's are different. For each of numbers being different, how many numbers are there? So for the 1000th digit, we have how many choices? Is that 4? No. For the 0, can it be on the first digit of the number here? It cannot. So 0 cannot be on the thousands. Where can it be? Yeah, it can only be on hundreds, on tens, and ones. So for the thousands here, we only can have 2 and 5. Altogether, we have 3 choice of the numbers. For the hundreds, right? Altogether, we have 4 numbers. For the thousands, we have already used up 1. And 0, yeah, this time it can be here. So how many choices are there? Yes, 3 choices also. So tens, we have how many choice? 2 choice. Ones, we have how many choice? 1 choice. So the total here, it is 3 times 3 times 2 times 1. So is the answer being 18 here? Is that the answer? So if you get 18, you can see none of the choices is correct. So there must be something wrong. Where is it? So when we get 18, it is based on what? It is based on every number is a different number. But now we have 2 2's, right? So for the 2 2's, if we assume that they have a different number, yeah, for the 2 numbers at the different cases, they will be the same. But now the 2 2's are being the same now. So altogether, for the 2 2's at the different places, we will make it being the same number here. So it is 18 number divided by 2, we'll get the 9 here, right? So the answer here is 9. So you may ask why? So for the 2 2 here, the first 2 and the second 2. So if we swap their positions, right? This 2 to this one, this 2 to this one, right? Will the numbers be changed? No. So that's why for every 2 different number, we will form 1 number if we have 2 2's here. Yeah. Okay. So yeah, finally we come to the short answer questions. And yeah, the first question. So Aiden is packaging a batch of cookies, and each bag holds 4 cookies, 20 cookies left unpacked, and holds 24 bags unused. So for this one, right, you can just set, we have X bags, right? You use the algebra and you will find it's super easy. So each bag 4 cookies. So 4x plus 20 is a number of cookies, right? So then he made each bag holds 6 cookies. So 6 cookies for each bag. And we know there are 24 bags unused. So it will be like this, right? So after it, we will know, yeah, we have built an equation here, right? And it's based on the total number of the cookies. So you can see 4x plus 20, it will be 6x minus 1, 4, 4. So 2x here will be 164, x here will be 82. So altogether we know we have 82 bags in total. So how many cookies does it have? So it will be 4 times 82 plus 20, right? So it will be 348. Yeah, 348 cookies. Or you can just calculate it by 6 times 82 minus 24. It is the same, right? It is the same. So yeah, this one, a fraction problem. Jason spent 1/7 of the money on pencil and 1/5 on a fourth on the mechanical pencil, 1/5 on a book. Yeah. So for this kind of fraction problem, right, we have a tool to help us. What is the tool here? The branching method, right? So here, yeah, we have the total here, and Jason first spent 1/7 of it. So what is the remaining here? 6/7, right? And then he spends 1/5 of it. Oh, not 1/5, 1/6 of it. So what is remaining here? 5/6. And here, right, we have spent 1/5 on the book. So what is remaining? 4/5, right? 4/5. And then, yeah, he stops here. And we know the remaining, it is this part, right? And we know it is $32 left. We have $32 left. So what is the fraction of the total will be equal to 32? You just use the chain rule, right? So the total, we times 6/7 times 5/6 times 4/5. Yeah, you cross it out, will be the remaining part, and it is $32. So it means the total, we times 4/7 will be $32. So what is the total here? Yes, it is 32. We divide 4/7, so it is $56. So the answer here, $56. Okay? Alright, so question 13 here. We need to count the number of rectangles in the figure here. Right, so of course you can just directly count 1, 2, right? 1, 2, 3. But then you will find we have so many of the rectangles here. You will count until next year, right? Once you count it, right, it is already 2026. So do we have another method to count this kind of rectangles? So first, in order to get the rectangles, do we have some special points to build them? So for example, if we have a rectangle like this, so what are the 4 vertices building it? Yes, they are here, 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 and here. So can we make them into the lengths here, right? We just make them to the lengths. So for these 2 points, we put it here and here on the lengths, right? For these 2 points, we put them here and here for the width. So for the whole rectangle, you make them into selecting points on the length and breadth, right? Or you can just say, oh, I want to select these 2 points. These 2 points on the length and these 2 points on the width. So what will the rectangle be like? Yes, it will be like this. Right, it will be like this. So you can see, once we select the points, you can get the rectangle here. Right. So how many different combinations are there for us to select the points on the length and the width? Right. This is the question here. So here, for the length, we have how many choices? 1, 2, 3, 4, 5, 6, 7. Yes, for the length, we have 7 choices. And for 7 choices, we need to take how many points out of it? 2 points out of it. So it is 7C2. So it will give you an answer of 21. For the width, right, for the width, we have how many numbers? 1, 2, 3, 4, 5, 6, 7, 8. Yes, we have 8 choices for the points in width, and we also need to select the 2. So it is AC2. The answer here is 28. Right, the answer here is 28. So then we know we have 21 different choices in length and 28 different choices in width. So what is the number of the rectangles? We take a pair of the points from the length, we take another pair of the points from the width, and place them together. We get the rectangle, right? So here it is just 21 times 28. There are so many combinations of the length and width, and each combination will give you a rectangle here. So it is 21 times 28. The answer is 5, 8, and 8. Yeah, 5, 8, and 8. Okay, so now we are going to this one. Suppose we have, it is also a permutation and combination problem, right? So we have 5 women, 6 men, a 4 people committee, and select at least 2 women here. So what are the cases for the women? So the total choices, it will be include 2 women, right? Also include 3 women. Also include 4 women. But will it include 5 women here? Will it include 5 women here? So let's see again. We have how many people in the committee here? 4 people in the committee. So how can a 4 people committee conclude 5 women here? It cannot be the case, right? So we cannot make it 5 women here. So it is just this case, right? 4 women, 3 women, 2 women. So we just calculate each part of it. So for 2 women here, it is 5 women, we choose 2 women, right? 5C2. And we have how many vacancies for the men's left? 4 minus 2, right? We have 2 vacancies for the men, and we need to select 2 out of the 6. So it is 6C2. So it will be 10 times 15 will give you 150. So it will be the same for the 3 women choices, right? For the 3 women, 5 women we choose 3, and we have 4 minus 3, 1 vacancy for the men here, and we choose 1 from the 6. So it will be 10 times 6. So the answer here is 60. So how about 4 women here? 5 we choose 4, right? So do we have vacancies for the men here? No vacancy. So it means we choose no man in this committee for 4 women. So no man is also 1 choice, right? So we put a 1 here. So it will be 5C4, which is 5 times 1, so it is 5. So then we can get the answer here, right? The answer is we just plus them together. It is 150 plus 60 plus a 5. So it is 215 here. Yeah, we have 215 ways. Or you can just think, we have a total, 11 people, we choose 4, and we minus those with 1 woman, minus those with 0 woman. It's also the same, right? It is also the same. Both ways will give you the correct answer. Yeah, I just give you this way. Alright. For this question, it's now a geometry. And now we know the diagram shows, the square have a side length of 80. So we put the things on the diagram, right? And we know the length for the rectangle is 100. And what is the breadth? So here, how can we link the side lengths together from the rectangle to the square? We need to use the area to bridge them, right? But how can we know the area between the EBGF and ADBC? So here, just one extremely important point, which is G here. G is on BC. And also we have A here. A is on EF. So you can see AB here is 1 point on the other side to this vertex. BG is also 1 point to the other side of the square to this vertex. So it means what? It means we can build a model here to make the bridge being true, right? So where can we build the model? Here. Yes, we link the AG, and then we can get the half model here, right? We link the AG, and we get the half model. So you can see the area of the AGB will be the half of the ABCD here, right? And also the AGB's area will also be the half of the F AFGBE. They are both half models. So you can see the AGB is the half of both. So yeah, we know it is the half of the both. So it means both of the area here should be what? Should be equal, right? So you can see ABCD will have the same area of the FGBE. So do we know ABCD's area? Yes, we do. It is 80 times 80, right? The side length is 80. So it is 6400. So 6400, it will be equal to the area of the FGBE, which is the 100 in length times the breadth. So breadth here will be 64. Yeah, so the breadth here will be 64. Alright, so any questions for the first 15? Yeah, for the first 15 questions? Yeah, if you have, let me see it. The question is so easy, okay? So yeah, oh, no questions. Okay, no problems, then maybe we should continue here, right? Maybe we should continue. So wait a minute. Yeah, let's start. So for the question 16 here, yeah, now we have question 16. And we have another average problem. So it is asking what? The average of all four numbers that can be formed by using digits 1, 2, 3, 4, 5 exactly once. So it means what? For the average, how can we get the average? The total minus the number of numbers, right? So here, right, how can we get the number of numbers? So it is also a permutation and combination problem, right? For the total number of numbers, we have 4 digits. So for the 1000 digit here, we have how many choices? 1, 2, 3, 4, 5, 5 numbers, 5 choices, right? For the hundreds here, how many choices? We have already used up one number in the thousands, so 5 minus 1, 4 numbers remaining. How about the tens here? 3 choices. The ones, 2 choices. So altogether, we have how many numbers by using the 1, 2, 3, 4, 5 exactly once? 1, 2, 0 numbers, right? We have 1, 2, 0 numbers. So yeah, we have got the total sum. So what should we do about it? Right? We also need to get the total. Right? But how can we get the total? Can we just list every number? You list every 1, 2, 0 number, right? One by one, and add them up, and you will die for it. Right? The calculation is so heavy. So we need one method. What should we do? We should also start with the thousands, hundreds, tens, and ones place. Right? So here, I have one example. So we just take out 1. Right? We have 1, 2, 3, 4, 5. We just take out 1. So how many numbers for 1 to be on the thousands place? For hundreds, we have how many choices? Yeah, we have 4 choices. Because, yeah, 2, 3, 4, 5, right? 4 choices. Hundreds, we have already used up 1 and another number, so 3 choices. And tens and ones, 2 choices, right? So we can get it is 24. 24 here. So how about 1 on the hundreds place? Also, thousands, 4 choices. Hundreds, yeah, it is 1. So tens, 3 choices, ones, 2 choices. 24. How about 1 on the ones? Not on ones. How about 1 on the tens digit? 4 choice for the thousands, 3 choice for the hundreds, 2 choice for the ones. And how about 1 on the ones digit? Also 4 times 3 times 2, right? 24. So you can see, no matter where the 1 is, it will always have 24 numbers. Right? It will always have 24 numbers. So will it be the same for 2, 3, 4, and 5? Will it be the same for the 2, 3, 4, and 5? Yes, it will be the same. Right? It's just substitute 1, 2, 2, 2, 2, 3, 3, 2, 4. Right? It will always be like this. So you can see, for each number on each 1 digit, we will always have 24 numbers like this. So we can just use the place value principle, right? So here, the total, it will be the 1000th place plus 100th place plus the 10th place plus 1st place, right? And each one will have 24 numbers for 1 being here. So will it be the same for 2 being here? The same. For 3 being here, the same. For 4 being here, and for 5 being here, they will be the same, right? So 1 on the 1000th place, we take 1000 here, right? 1 on the 100th place, we take 100 here. 1 on the 10th place, 10 here. 1 on the 1st place, 1 here. We have 24 numbers, and here is a 1. The same for 2, the same for 3, the same for 4, the same for 5, right? So we can get the total. So now we can get the answer here, right? The answer is 1000 plus 100 plus 10 plus 1 times 24 times 1 plus 2 plus 3 plus 4 plus 5, which is a total, and we divide the 1 to 0, which is the total number of the numbers. So yeah, we know this is 1111, right? And 24 and 120, we'll have a 5 here, and this one, yeah, it is a 15. So we cross it out, 3 here. So it is 1111 times 3. 3, 3, 3, 3. Yeah, this is how we get it. 3, 3, 3, 3. Okay. Yeah, now, another ratio problem. Nico and Josh have same cars. Yeah, so for this kind of ratio problem, the first question, what is a constant here? Is a total constant? No, Josh lost 4 of the cars. Is Nico and Josh, each one of them having the constant number of cars? No. Is the difference being the same here? No. So nothing is constant. So we should do what? We use an algebra to solve it. So now we have Nico and we have Josh. So initially the ratio is 3 to 2. So yes, we can make it as 3 units and 2 units, right? So Nico, Josh, 3 to 2. So Nico 3 units, Josh 2 units. So the initial will be like this. So after it, so for now, yeah, we know Josh lost 4 of the cars. So 2u minus 4. He lost 4. And Nico gave 20 of the cars to Josh. So Nico gave 20 of the cars. Nico's car should be 20 less, right? She gave it away. And for Josh, he received 20 cars from Nico. So the number of his cars should be plus 20, right? And now we know the ratio here will become 5 to 7, right? So you can see the 3u minus 20 to 2u minus 4 plus 20. It will be equal to 5 to 7. So this is the equation we built. So how can we calculate this ratio equation? Yes, we use the inner times inner with the outer times outer. These two parts. We time it together. So it is 5 times 2u plus 16. Will be equal to 7 times 3u minus 20. So it will be 10u plus 80 will be equal to 21u and minus 1 for 0. 11u will be equal to 2 to 0. U here will be 20. But u here will be 20. So yes, we know 1 unit is 20. So it is asking what? The initial number of the cars Nico had. So initial number of Nico has how many units? 3 units. So it is 3 times 20. 60, right? So yeah, it is a difficult ratio problem. But once you know how to use the algebra to express it, it will be super easy, right? All the difficulty here you met is about the calculation, right? This is a typical question that Amos really like to just test you. So I think you need to have a good command of this kind of methods. Yeah, this is it. So now question 18. Number series question. So we have 20, 56, and 68. Will give the same remainder when divided by an integer larger than 1. So what is the maximum value of the integer? So here, yeah, we have a remainder divided by an integer. So we just set the integer as what? As the x. And we set the remainder as y. So here we have set the integer and remainder. What is the use of it? So we can, based on x and y, to express the 20, 56, and 68. Right. So 20, it will be the quotient. We set it as x. So ax plus a y, it is 20. So 56, it is what? Bx plus y. Right. And 68 will be cx plus y. So yeah, we have so many letters here. So how can we get the answer for x and y? We don't need to get it, right? We only need to get the x here. So if we know, yeah, we are having the same remainder. So it means when we make the difference of it, the difference, it must be what? It must be a multiple of the divisor here, which is x. So you can see 56 minus 20, it will be what? It will be bx plus y minus ax minus y. So my y here, they are crossed out. So we have b minus ax, and this is 36. So here we know a, b, c, they are quotients. So it means a, b, c, they are integer. So if we know a, b, c are integer, b minus a is what? Also an integer, right? B minus a is also an integer. So we can do it again, right? So 68 we minus 56. It is cx plus y minus bx minus y. Y go away. So it is c minus bx will be equal to 12. So this one is also an integer. So once we know these two integers, we can know what? Yeah, why I'm going to tell you they are integers? Because once we know the integer, we know 36 is a multiple of x. 12 is a multiple of x. This is the key in this question. So once we know the two integers here, we know 12 and 16, they are both multiple of x. So we want what? The maximum value. So x should be what? X is the highest common factor of 12 and 36. And we know 36 is 3 times 12. So yeah, the x here is 12 for the LCM. So maximum 12. Okay. So yeah, this question, a clock problem. So yeah, it will just appear in MOS, I think, but not that frequently. So now we have a clock shows 5:52 p.m. and we need to find this angle, the obtuse angle, between the hour hand and the minute hand. So here, how can we get it? For the clock problem, the first thing for us to do it is to get the speed of the hand. So do you still remember the speed of the hour hand and the speed of the minute hand? So for minute hand, right, for the minute hand to turn around, will be like this, right? It will just turn how many degrees? 360 degrees, right? And it will take him how many minutes? 1 hour, so 60 minutes. So you can see it is 6 degrees per minute, right? So how about the hour hand? Yeah, for turning one circle, it will take him 12 hours. So it is how many minutes? 12 times 60 minutes. So it's 0.5 degrees per minute. So yeah, we have already got the speed of the hand here. So how can we get the degrees between them? So for this clock problem, you can also think it is a kind of journey, and the degrees is the distance, right? We have the speed, we have the time, so of course we can get the distance here. So we know it is 5:52. So we set this one as a starting point. So if we set this as a starting point, how about the minute hand? Yeah. So the degrees to the 12, which is the start here, for the minute hand, originally for the starting point it is 5 o'clock, right? It is 5 o'clock. So originally it is 0 degrees. And the minute hand has traveled 52 minutes and at a speed of 6 degrees per minute. So this is the degrees from the starting point for the minute hand, right? So it is 52 times 6, 3, 1, 2 degrees. Yeah. So how about the hour hand? So at 5 o'clock, is it heading at the 12 here? No, it will be heading like here, right? Or it will be like heading here, right? 5 o'clock. So originally, it will have some degrees with the starting point. How many degrees are there? So 360 degrees, right? For the total of 12 hours. And we have already get 5 p.m. So it means we already have 5 over 12 here. And then based on it, he traveled for 52 minutes. So it's 52 minutes times 0.5 degrees per minute. So it will be like 150 plus 26, 176 degrees. So we know the answer, right? So we know the answer. It is 312 degrees minus 176 degrees. So it is 136 degrees. Yep, 136. Okay. Now we have the last question in the section B here, and yeah, this is a question from MBOS, I think, and a new category of the questions for this year. So here, 20, and we have a pyramid, and which of the following fits into the blank circle for the top pyramid? So once we have the pyramid here, you need to think about the layers, right? The fourth layer, the third layer, the second layer, and the first layer, right? The 4 layers here. So when we see the fourth layer and the third layer, we need to find the connection between them, right? So for the pyramid here, we have a very typical form like this one. This one is a very typical form. So we have these two at the bottom layer and this one at the upper layer. So why? What is the connection between these two layers? So we need to draw it out, right? So first we have a shape like this, right? And then we have a shape in the right bottom corner. So I use another color to help you to draw it. So we have a shape like this, and we have a point in the middle, this one, and this one, right? So after it, you can see, yeah, we have an overlapping part. So what is the difference between the overlap between this figure and the upper layer for here? Yes, the overlapping part is gone. So it means we need to remove the overlapping part. So we can get this kind of shape up here, right? So is this category being the same? Is this theory being the same for the others? We just take another to examine it, right? So for here, I take this pyramid to examine my guess. So originally, yes, we have a figure like this. And yeah, we have another figure here. So we have one overlapping part here, we have orange, we have overlapping part here, and we have a dot here. So yes, these two are already overlapping, so we remove it. And this line and this dot, we also remove it, right? So these two parts we remove. So what will happen left? What will be left? The two lines here, right? This one, yes, you can examine it. It will be the same. So now you know the rule here, right? So how about this point? Yeah, it is based on these two. So what are the overlapping part? These two horizontal lines, right? These two horizontal lines. So the shape will be like what? Yes, these two will remove the two horizontal. Will be like this, right? And then based on this, we can get the top one, which is the answer here, right? Based on these two. So the bottom line, yeah, remove. The middle one and the line remove. The right one remove. What is the left? The diagonal and 1 here, right? This is it. So what is the answer? 304, right? The answer here is 304. So yeah, just filling it like this. Alright, so for the first 20 questions, do you have any problems here? I think it is not that hard. Yes, I think it's not that hard. No, no, no. How about others? Okay, good job. So yeah, let's go to the question 21 to 30. This part is a little bit hard, especially for the 5 questions here. The last 5 questions. It's super hard. I think it is. So yeah, let's go back to it. So question 21. Wow. We have 11 vertices and given 11 pointed star, and we want to find the sum. And there's nothing left. We don't even know one of the angle here. So how can we get the total sum of it? So for this kind of question, right, there is a fastest way. Yeah, you can solve it by the exterior angle theory. You can solve it by building some triangles, right? But the best way to solve this kind of question is to use the sum of the interior angle sum, right? The sum of the interior angles for the polygon here. So here, how can we build a polygon? We need to add some lines here, right? So for example, teacher Kevin, teacher Jikai will give you 2 lines here. Yes, build the line like this. So what angles will be included in these lines? In this polygon A3, A4, A8, and A10. Yes, we have already got 4 lines included. I label it in an orange color. But these 4 are already in it. So how about A11 and A7? Are they in it? Yes, of course. Why? Because you can see we have a triangle like this, right? And we have a triangle like this. They have both the interior angle sum of 180 here, and we know this part is a cross angle. This one and this one. Cross angle, always the same. So it means 100 divided by the same number. The difference here is also the same. So it makes A11 and A7. Yeah, they are also inside this interior angle here, right? So yeah. So A11 and A7, they are also in it. Right? A11 and A7, they are also in it. But how about these 2 angles? Do we have a value here? It is not equal to any of it. But we can build a part of it to make something represented in these 2 angles. So how can we build it? We add another line here. We link A1 and A6. Right. So you can see, yes, we have also 2 angles here, right? The cross angle is these 2. So the other 2 angles, they have the same sum. So yeah, these 2 are also inside the exterior angle of it. Right, exterior angle of it. So then, what is the things being left? We have the red part being left, right? This angle we do not know. This angle we do not know. And we don't know A2, A5, and A9. But for A2, A5, and A9, can we build a line to make the other 2 angles being shifted into another interior angle of this triangle here? Of course, we can link A2 and A5. So it will be included into this angle and this angle, right? So now we have already transferred all of the angles in the vertices into the exterior angle of a quadrilateral and a triangle. So the answer here, it will just be equal to the interior angle sum of the quadrilateral. So it is 360, right? And the interior angle sum of the triangle, which is 180 here. So the answer here is 540 degrees. Yep, 540 degrees. Alright, question 12. What is this? Oh, we have 10 prime numbers and we want the maximum integer of the x. Quite familiar. So 7 prime numbers in the numerator and 3 prime numbers in the denominator. Yeah, we just throw it out. So I don't care about it. Why? Because we are having the largest integer here, and it is the relationship between the numerator and the denominator. So yeah, we can just set these two parts, right? We can just set these two parts. So we can make the total of 10 prime numbers into two parts, and x is the link between them, right? So we set it as a here for the denominator. So denominator should be a times, right? This is a. So we move it to left port for that. So it is ax here for the denominator. So yeah, we know these two parts is a plus ax. The sum of it, a plus ax, right? So how about the other side of the equation here? The 10 prime numbers should be added up together, right? So it will be a plus ax equal to 2 plus 3 plus 5 plus 7 plus 11 plus 13 plus 17 plus 19 plus 23 plus 29. Yeah, that's it. So a plus ax is this part. So what is it? A times, right? So this part we can extract the a here out of it. So a times x plus 1 will be equal to what? You just add them up, right? Do the calculation here. And I will tell you it is 1, 2, and 9. So yeah, we have got this equation. But what is the next step? So here, right? For a, is a an integer? A is the sum of the prime numbers, right? The prime number, they are integer. So the sum of it, of course, it is integer. So x here, integer, right? So it means these two parts are integer. So it means they are also the factors of 1 to 9, right? So we can do the factorization for the 1 to 9. And once you do the factorization, you can see 1 to 9 is only what? It is only 3 times 43. So you can see, a times x plus 1 is 3 times 43. So you know there are two solutions for a the x plus and x plus 1, right? So it is a equal to 3, x plus 1 equal to 43. Or it will be a equal to 43 and x plus 1 equal to 3. So is a here being 3 being possible? So for here, the denominator, 3 prime number adding up together, can it be 3? Of course not, right? It cannot be 3 here. So how about 43? Can we have 3 prime numbers making the denominator, which is 3 part adding up together, will give you a 43 here? Yes, we can just select it. We can select 3 out of it, select 17 out of it, and get a 23 out of it, right? And we know, yeah, it is 43. So we have already verified that a here equals to 43. So what is the x here? Yes, x here is 3 minus 1 will give you a 2 here. This is x. So the x here, 2. But it is asking the maximum possible value. But here, the tricky part is we only have one possible value for x. Yeah, and of course it is a maximum. 2 here, right? 2. Yeah, for this one. Product of 5, 10, 15, 20, blah, blah, blah to 2025. Yeah, of course it is a question given from the 2025's contest. And how many consecutive number of zeros at the end. So here, but for the numbers at the end, what will form a number at the end here? So everybody knows that 2 times 5 equal to 10, and then we have a 10, we have a 0 at the end. So we have something, for example, 13. So 13 times 2. The 0 here, it will also remain on the end, right? The 0 will also be on the end here. So here, yes, the question is from how many consecutive zeros at the end to what? To find. We need to find how many 2 times 5 pairs. How many 2 times 5 pairs? So let's just observe the 5, 10, 15, 20, blah blah blah. So 5, 10, 15, 20, blah blah blah, right? So you can see every 5 we will get a multiple of 5 here, right? 5, so multiple of 5. 10 with plus 5, multiple of 5. 15 plus 5, multiple of 5. And then how about multiple of 2? What? 10, 20, 30, blah blah blah. So it is every 10 number we get multiple of 2 here, right? So when we are going to have 2 times 5 pairs, so the 2 times 5 pairs, it is equal to the number of 5 or the number of 2 here. The number of 2. Because the 2 here is the smaller number, right? The number of 2 here is a smaller number. So here, right, how can we know how many 2 here? Right. So if we take it out, it will be 10, 20, 30, 40, 50, blah blah blah, right? So 10 here, we know 2 times 5. 20, 4 times 5. 30, 6 times 5, 2 times 3 times 5, blah 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 blah, right? So you can see for the 10 here, it contains a 2. It contains 2. So it is from 5 to 20, 25. We have 20, 20. So it is 20, 20. We just divide by 10. Right. We have 202 numbers. It is existing in this 5, 10, 15, 20, blah blah blah. We have 202 numbers, and they contain a 2 here. So once we know they contain a 2, how about a number containing 2 2's here? It will be 20, 40, 60, 80, blah blah blah, right? So it will be 20, 20 divided by every 20 numbers. So it is 101, right? So you can see, based on this, how about those who have a multiple of 8, which contains 3 2's here? The 40, the 20. So it means for this 101, every 2 number we will have one having 3 2's. So it is 101 divided by 2, right? I'll give you 50, right? So how about containing 4 2's? 25. How about containing 5 2's? 12. How about containing 6, and we have 3, we have 1, right? We have know all the categories for the numbers containing 1 2's, 2 2's, 3 2's, 4 2's, blah blah blah, until we have 8 2's. So how many 2's are there? So here, right, for the number which is a mode of 4, does it exist in the number which is mode of 2 here? Yes, it exists. So it means for one of the 2, it is calculated in this 202 here, and another 2 is calculated in this 101. So how about the number which contain 8 2's here? 1 2 in 202, 1 2 in 101, 1 2 in 50, in 25, in 12, in 6, and in 3, right? So only have 1 2 being left. So it means for every number, the 25 here, we only need to add 25 on it. So how many 2's are there? We have 202 of the mode of 2 here, and 101 extra 2 for the mode of 4, and 52 for the extra and 50 extra 2 for the mode of 8, right? And 25, 12, 6, 3, and 1. So if you add them up, it will give you an answer of 400. Yeah. So altogether, we know we have 400 tooths here. So 400 tooths here, and we know, of course, the number of 5 is larger than 400. So it will form how many pairs of 2 times 5? 400. So it will generate 400 tens and 400 zeros at the end. So this is the answer. Okay. Yeah, and now we have question 24. Yeah, we have a number table again, and the first column contains 1, the second 2, 3, 4, the third 5, 6, 7, 8, 9. So yeah, before you get the 30th number in the row, you need to first observe the something special in the number form. So where is it? So we have a 4, we have a 1 here, we have a 4 here, we have a 9 here. So do you find the pattern here? Yes, this is the first row, the first column, right? We write the column. The first column, the second column, the third column, the fourth column, blah blah blah. So the first column, yeah, we have a 1 here. It means what? It is 1 square. Right? 4 it is what? It's 2 square. 9 is 3 square. Yeah, the last number on the column, it is always equal to the column's number squared. So here, the 30th number in the row, which is started with 1. So it is the 30th number in the row, which is the 30th column, right? So the end, it is what? The number of the column, 30. Take a square, right? 900. And then, yeah, we know the number in the end, but it is asking the number started with 1, which is in the middle, this row. So how can we shift the row, the last row to the middle of the row? Right. So 4 here, we go to the middle of the row, we minus 1. Right. 9 here, we go to the middle of the row, we minus 2. So for example, for the 4th row, right, we go to the middle, we minus 3. Right. Second column minus 1, third column minus 2, fourth column minus 3. So 30th column we minus what? Yes, 30th column we minus 29. So middle row in 30th column, it will be 900, which is at the end, and we minus 30 minus 1. Right. So it is 900, we minus 29, so it is 871. Yeah, the answer here is 871. So once you find the pattern, yeah, it is super easy. This question is not that hard. You get the pattern, you find, oh, how can we get the number we want? Yeah, you get the way you just do the calculation. Not that hard. Alright, question 25. Okay, so we have a polygon like this, and we know it is 120 degrees. Okay, so here, right, when you see this kind of irregular shape, what is it? Answer here. You can't know it, right? It is asking the parameter, but we don't know the two sides here. But however, when we get the irregular shape, we can make it as the regular shape here, right? We can make it as a regular shape. How can we do it? We just make it into something like this, right? We compensate 3 equilateral triangles here, right? You can prove it is an equilateral triangles, but it's hard, right? So you can just assume, yeah, they are equilateral triangles. So what will happen? This is 4, right? So we know this part is 4, this part is 4, this part is 4, and this part is not 4. This part is 1, right? Sorry, this part is 1. So this part is 1 and 1, and this one we don't know. But however, once we compensate the 3 triangles here, the large equilateral triangle, we have now the side length, right? It will be equal to what? This right side, right? It is 1 plus 4 plus 4, which is 9. So it means we know this part is 9 and we know this part is 9, right? So we know this is 3, this is 4. So what is this part? 9 minus 3 minus 4, right? So it is 2 here. So 2 and 2. And how about this one? Yes. 9 minus 1 minus 2. So it is 6, right? So here it is 6. So the answer here, it is just we add all of the sides together. So it will be 1 plus 4 plus 4 plus 4 plus 3 plus 1, 4, 4. Not 4. 3 plus 2 plus 6. So, yes. What is the answer? Let me have a check. Yeah, it is 20. Yeah, it is 20. So, answer here, 20 centimeters. Yeah. Okay, now we have another number table here. And now the first column, yeah, it is from 1 to 99. So altogether we have how many columns here? We have 99 columns. Right, we have 99 columns. So we want to know what? The number never appears, right? The number never appears. So for 99, what is the number that doesn't appear in the first row? 100. Where is 100? Here. Right. So how about the number after 100? 101, it doesn't appear, but it appears on the next row, right? So how about 103 here? Yeah, it's here. So what is the number after 105 doesn't appear? 106. So it is here, right? So you can see, when you just calculate all the numbers that doesn't appear, and you find it in the next row, you will find you have built another triangular number form here, number table. So we want to know the smallest number that doesn't appear. It means what? It means once we get the number after the row, it won't appear in next row. It will appear like this in here, right? And something plus 1. It will appear like this. So in this column, left than this part, it will appear. Right. So for this kind of question, it's calculating how many numbers in the triangular number form. So we have first row 1, right? Second row 2, third row 3. So how many rows are here? Right. You can see the first column 1, right? 2 column 2 row, 3 column 3 row, right? So we have 99 column. So layers, we have 99 rows. So first row 1 number, second row 2 numbers, third row 3 numbers, until we get 99 rows. So we have how many numbers? We have 1 plus 99 times 99 divided by 2. So it is 4950. Right. So we know there are altogether 4950 numbers in this triangular number sum until we get blah 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 blah. Right. Altogether we have 4950. So what is the number in here? Right. What is the number in here? Where does the number will start? It starts with 100. Right. So it is, we start with 99 numbers before it and we plus 4950. So this is how we get it. But is this the final answer here? Right. So 99 plus 4950, it is 5049. Where is it? It is the last number on this triangular number form, right? So the number after is 5050, and it is 5050 that appears on the most left of the next layer, and it is not in this line, right? So the answer here is we need to plus another one. So it is 5050 here. All right. Okay, yeah, question 27, I think it's also hard. So each card with a different value from 1, 2, 3, 4 until we get 13. Yeah, so it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, we have 13 numbers. So A said what? Among the three of us, no one holds a card whose the value is the product of other two. So how can he know this? So he doesn't know B and C's number, right? But how can he assume the number is not a product of other two? Yes, it means his number, it won't happen in the equation of a number is other two. So what are the total of the equations for a number is the product of other two? It is like 2 times 3 equals to 6, right? 2 times 4 is 8. 2 times 5 is 10. 2 times 6 is 12. 3 times 4 is 12. So, if A's number is in one of the numbers appear in these equations, he's not sure. But if his number is outside these equations, he will know, okay, for these equations, all of it will at most have 2 numbers of the 3. So it will not happen for a number as a product of other two. Right? So it means A here is not 2, is not 3, is not 6, A 10, blah blah blah. Right? All the numbers appeared in those equations, it will not be the number held by the A here. So yes, you can just cross 2, 3, 4, 5, and 8, 10, 12 out of it. So A have a possible number of 1, 6 also out, 7, 9, 11, and 13, right? A's possible number should be like this. So we know about the A here. Yeah, it is done. And how about B? At least one of you two does not hold a constant number. Yeah, how can he know this? So does B know C's number? B doesn't know C's number, right? But how can he know U2 doesn't hold a constant number? He doesn't know C's number. So he must know A don't have a prime. Yes. Not prime. A don't have a composite, right? So he must know A don't have a composite. So among the A's choices, right, only 9 can be a composite number. So yeah, it is like A don't have a composite and A can only have 9 as a composite number. So how can B knows A don't have 9 here? Because 9 is in B's hand, right? B said, I have the 9. So I know A, you don't have the 9 here. So you can only have 1, 7, 11, 13. So yeah, you know, B has a 9 here. The 9 here is in B's hand. So B know, okay, A, you don't have a 9. So you can only have 1, 7, 11, 13. So no composite. So A and C, you two don't have a composite number. So this is a B. How about a C here? C said, the sum of my card and A's card is definitely a prime number here. Right? So C means C plus 1, C plus 7, C plus 11, and C plus 13. It is a prime. So how can you know this? Yeah, you just have to try. So you can know C will be equal to 6, right? The only value for the C here will be equal to 6. You can just try it. Yeah. For this part, I don't have some better method. You need to try. So once we know B and C, and then A says what? A said, it seems my card is neither the largest nor the smallest. So it means A's choices is between 6 and 9, right? 6 smaller than A, smaller than 9. So what is the choice between 6 and 9 for A here? 7, right? So we know A equals to 7. So the answer here is asking what? The product of the A, B, and C. So it is 7 for A and 9 for B and 6 for C. So it is 7 times 9 times 6, right? 7 times 9 times 6. So the answer here is 378. Yeah, 378. Alright, this one. In the following number puzzle, all the numbers in the boxes are different. And what is the greatest? Okay, For this one, yeah, you need to know one thing, which is when we add different addition numbers for one equation and have a sum of another equation, the digit sum of them, when we mod 9, it is always the same, right? So we know every number are different, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. We have 10 boxes, and 10 different numbers should be filling it. It means what? It will have 0 to 9. Everyone we will have fill in once, right? So it is like we assume this one is J here. So this part is 1, 2, 3, 4, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Right, 10 numbers except for J. So every number should be filled in here. Right. So how can we get the digit sum here? It is like 2 plus 0 plus 1 plus 5 plus, yes, 1 plus 2 plus blah 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 plus 9. And we minus the J. It is the digit sum for these 4 numbers, right? And it will be equal to the remainder divided by 9, right? For the sum of it, 8 plus J plus 2 plus 8, when we mod 9. Yeah, when we mod 9. So you can see this part when we add it together, it is 45 plus 8, 53, minus J. We'll have the same remainder as 18 plus J when we mod 9. So you can see it will be 8 minus J will have the same remainder with J, yeah, when we mod 9. So it is like 8 minus J will be equal to J. J here is 4. Right, J here is 4. So you may say, Teacher Kevin, I don't understand this part. Can I just use the traditional way to try it out? Yeah, you can do it like this. You can try it out. But I will tell you, you will waste some time for it. Right? It's also another way for you to use the traditional method to figure it out. But it is not the best way to do it. Okay? So once we know J here, it equals to 4. Right? So here, how can we get it? So we want it to have the largest possible, right? The greatest possible. So we just try for this number. We have 9 and 8 left. So why not we fill in 9, fill in 8, and have a try whether it will work for the equation here. Right? So we have 9 and it is something 4. Right? Can we have a number to make it 24 and we have a carryover 2 here? No. Right? The largest is 7 here. We cannot make it 2 here. So the only thing here will have the carryover of 1. So carryover 1. So what will the number being here? 5 here. Right? So yeah, this is it. We get a 5 here. And we have also a 2 here. Right? We also have a 2 here. So how can we get a 2? What is the maximum carryover here? We just fill in the largest number. For example, 7, for example, 6. Right? So it is 8 plus 7 plus 1 plus 6 plus this carryover. We name it as C here. It will be equal to, what is it? 22 plus C. So yeah, the largest carryover here, it is 2. So it is 9 plus 0 plus something plus 2 equals to 4. So what should be the answer here? Yes, the answer here should be 3. Right? It's like 9 plus 0 plus something plus a 2 equals to 14. So this one will be equal to 3. Yeah. Now you get this 3 here. Right. And now we need to determine whether this carryover 2 can be the correct one. Right. So yes, we know 7 and 6, they are correct. But what if it is not 12? It is not 22. It is a 12 here. Right. So once if it is not a 12, right? So how about the first digit? So here, let's say it like this way, right? 22 plus C will give you 22, right? So C here at this time should be 0. But can C be 0 here? Right? Can C be 0 here? We have 0, 1, and 2. We add them up, 8 here. So can C become another number? For example, C equals to 1 here. So this column we have an 18. So it is something plus something plus something plus 5 will give you an 18 here. So you can see something plus something plus something will give you 13. Right? Something plus something plus something will give you 13. So once you get it, what is the largest number? We have already used up 7 and 6 here, so we cannot get the 13 here. Right? The carry over here can only be 0. 13 is not possible here. So C here must be 0 if we want an 8 and something here. Right. So here we can only have 7 and 6, and this one is 0 to 1. So the 2 is the largest one, so 2 here and 1 and 0 here. So you can see the largest is 2982. Right. Yeah, this is it. So any questions for 28? 28, I think it is the hardest question in today's paper. Yeah, and I think it's not that hard to understand, not that easy to understand it. Yeah, I think it is the hardest question here. Why not 2, 3, 1? If we have 2, 3, 1, we will not get an 8 here. Right? We will not get an 8 here. Okay, then I just continue here. Okay. So here, last we have 2 questions. We arrange 1 to 100 natural numbers into it, and we want the largest and the smallest numbers obtained. So let's start with the largest here, right? So for the largest, we will have just, for example, 99 something, right? 99 something. So if we want to have 99 something, right? So here, how can we get 99 something? 99, 100. This is 99 something. And is that possible? So how many digits are there? For the 1-digit number, we have 9 numbers here. And for the 2-digit number, it is 98 minus 9. These 2-digit numbers. So each 2-digit number, we have 2 digits. So times the 2. So if we divide by 3, you will find it will be 62 remaining 1. So it means we don't have a whole 62 3-digit numbers here. It will remain 1 digit here. So what will it be like? It will be like this. 899 will form a group. So no. So do we have another? We'll give you a 99 here. Yes. 89, 90 here. Right. So we will have 990. So if we have 990, will it be possible? 9 plus, right? And as we have 89 here, so it is 88 minus 9 times 2, right? And we have an 8 here, right? So we need to plus a 1, divide by 3, right? So it is like this. And we know it is 56 remaining 0, correct? So the largest here, we know it is 990. So how about the smallest? So for the smallest, yeah, we make the first digit become 0 and 0 something something. So is 0, 1, 1 being correct? Like 1, 0 and 1, 1. Is 0, 1, 1 being correct? No, we already know it is 1, 0, 1 and 0, 1 and 1, 1, 2, right? It will not happen. So what is the next thing with the 0 here? Yes, 20, 21, 0, 2, 1. Is that correct? So 9 plus, so it is 20, right? So it is 19 minus 9. So we times the 2, and do not forget we have a 2 here. So we need to plus a 2, plus a 1 here. So we divide by 3. So this 10 remaining 0. It means, yeah, we have 10 3-digit number forming a group here, and we have 0 to 1. So 0 to 1 will be the answer. So the total of the answer here will be 990 minus 0 to 1, which is 990 minus 21. We will give you an answer of 969 here. This one. Alright. So finally, the last question. Yeah, we have Mark and Ethan, right? So this is a circular runway, right? And this is the starting point. We have Ethan and we have Mark. So first, they will walk in different way, opposite directions. So for example, Ethan walk like this, right? So for example, Ethan will walk like this, and Mark will walk like this. And then they meet for the first time, right? They meet for the first time. And then do what? And then Mark will turn back, right? Mark's direction will come like this. So here, for the first meeting, what is the distance between the meeting point to the starting point? Right. We need to know the distance here. So what is the time? It is an encounter problem, right? You can see for the first, they are moving in the different directions. So it is encounter. So the total, it is 400 meters divided by the sum of their speeds. So it is 50 seconds. So this is time. So distance, it will be 50 times 3, which will be 150 meters here, right? So it will be 150. Okay, so like this. And after it, Mark has turned back, and Ethan will make the same direction. So this point, the second meeting, right? The second meeting, it is an encounter problem or chasing problem. It is a chasing problem, right? This is Mark's direction and also Ethan's direction. This is a chasing problem, right? So here, the time, it is 400 divided by 5 minus 3, right? It is 200 seconds. So the distance, it is 200 times 3, it is 600 meters. And originally we have 150, right? And we go back for 600 meters. Because, yeah, for all the starting point and ending point, we always focus on Mark's location. So we go back for 600 meters, and you can know the answer for the second meeting point. It is 600 minus 150, which is 450 meters. So it means we go back for 450 meters. And it is a circular track, so it will be equal to 50 meters here, right? So it will be equal to 50 meters. So the distance between it is 50, right? And then how about the third chasing point? The third meeting point. After they met for the second time, right? Ethan will turn around. So it will be like this. Ethan changed the direction. So the third. And Mark, his direction will be the same. So again, they are having the encounter problem, right? So it is 400 divided by 5 plus 3. Yeah, and it is 50. So 50 times 3, it is 150 meters. Right. So here has got another 150 meters. But now, where is Mark's direction? Also hiding in this way, right? So he goes for another 150 meters. So you can see, yeah, it's now 200 meters from the starting point, right? 150 plus 50 will be 200 meters. So how about the fourth meeting point? So for the fourth, yes, Mark turned back like this, and Ethan the same direction, right? So they are also having the chasing. So it is the time 400 divided by 5 minus 3. So it will be 200 seconds. So 200 times 3 will be 600 meters. So in which direction? In this direction, right? 600. So originally, yeah, it is 200 here, but it's 200 here. So 600 minus 200 will be 400 meters, and it will be equal to 0 meters. So the starting point will be just here, right? So after the force, you can see Ethan is going in this direction and Mark is going in this direction, and this meeting point is just a starting point. So it means what? It means every 4 meeting we will form a cycle. So now we have 99s, right? So 99 we divide by 4. It is a cycle problem. So we have a remaining 3. So remaining 3, just the third meeting point, right? So altogether we have 200 meters. Yeah. So this is the end of our paper for the TASMO sample paper 1. Yeah. So do you have any questions, or if you don't have, then it is the end. Yeah. No, good job. Yeah, I don't have. Good job. So then maybe I end our today's live here. And yeah, if you have some questions, you can watch the playback. So that's it. Yeah, I end it.